All right, welcome to our deep dive. And today we're tackling something pretty fundamental in AI. We've been exploring all these fascinating areas of AI, and today we're going to really zero in on Clause 6 of this ISO IEC 22989.2 Year 22 standard. You kind of think of it as the master plan, the blueprint for AI systems. It lays out all the stages, from when it's just a glimmer of an idea to when it's finally put to rest.
Yeah, exactly. It's like our crash course, AI systems 101, the life cycle, the whole shebang. And the cool thing about Clause 6 is it's not just like a static description, right? It's like this dynamic story, this narrative of how these systems evolve over time. And what we really want to do today is unpack this AI system life cycle model, go stage by stage, process by process, really break it all down. Because when you understand this framework, you get this incredible insight into the whole journey of an AI system, from its birth to its eventual, retirement.
Okay, so let's jump right in. Let's talk about the heart of it, the AI system lifecycle model itself. What's it all about?
Well, the model basically maps out the entire lifespan of an AI system, right? From that initial spark, that first idea, all the way to the point where it's no longer being used. And here's a really important thing to keep in mind. ISO IEC 22989, it doesn't force everyone to use a single rigid model. It's more about highlighting these key processes that are super relevant to AI systems, no matter where they are in their lifespan.
It's more like a guide, right?
Uh,
A set of best practices rather than some strict, step-by-step manual.
That's a great way to put it. And one of the most crucial aspects to grasp is this whole iterative nature of the life cycle. It's almost never a straight line from point A to point B. Stages can be revisited. You can go back, repeat things as needed. Like, imagine you have an AI system that's already out there working in the real world, and then bam, you discover some pesky bugs or you realize you need to add some new features. Well, guess what? You might have to circle back to the design and development stage to make those changes.
Makes sense. It's not like building a house, right? Where once it's done, it's done. With AI, it feels like this constant process of evolution and refinement. Speaking of that, are there any big differences between this AI system lifecycle and how we usually develop traditional software?
Oh, absolutely. There are some fundamental differences that come from the very nature of AI, the way it works. Like, think about this. AI systems, they often need way more iterations, more cycles of fine-tuning to reach that level of performance we're looking for. And that's way more than what we typically see with traditional software. Think of it like training a machine learning model, for example. It's all about constantly tweaking it, refining it based on the data it's getting. It's this journey of exploration, of learning, and it's driven by how the data performs, not just how the code executes.
Yeah, so it's not just about writing code. It's this intricate dance between the system and the data it's learning from.
Precisely.
Yeah.
And then there's this whole challenge of verifying AI systems, which is different too. With traditional software, you can often test it in a very structured way, predict the outcomes. But with AI, especially those systems that are learning from data all the time, things get trickier. We often have to rely on statistical methods to really evaluate their performance and make sure they're reliable, not just in a few specific scenarios, but across a whole range of inputs, a variety of situations. Because AI isn't always as predictable as traditional software, it learns and adapts. And so we use these statistical methods to understand its performance and ensure it's trustworthy across different situations, not just specific test cases.
It's like it's not as deterministic, right? It's not all pre-programmed in the same way.
Exactly. And then there's the whole data management piece, which is huge in AI. Things like data acquisition, getting all that raw data, annotating it, which means labeling it and giving it context, preparing it, cleaning it up and formatting it, making sure the quality's good, sampling, which means picking the right subsets of data, and even augmentation, creating new synthetic data from what you already have. All of these things are super important in AI, maybe even more so than in traditional software.
Yeah, data isn't just something it uses. It's like the lifeblood, the fuel that drives the whole development process.
I like that, the lifeblood.
Yeah.
And of course, development and testing in AI, they're heavily influenced by how much data you have and how good it is. And if you're dealing with these continuous learning systems where the AI is always learning, even after it's been deployed, well, you need to keep testing and validating it throughout its entire life, its operational phase. And then there's release management, which is also more complex. It's not just about managing versions of the code. You also have to manage versions of the models themselves and maybe even the data sets that were used to train them.
Wow, that's a lot to keep track of. Code, models, data, all in sync. It really shows how complex these systems are. Now, I noticed the standard mentions Figure 3 and Annex A. Should we take a look at those visual aids?
Well, since this is an audio deep dive, we won't get into the nitty-gritty details of Figure 3, which shows the life cycle model stages visually, and Annex A, which maps it to how the OECD defines AI. But it is helpful for you, our listener, to know that these visuals are there in the standard. They provide extra clarity and different ways to understand the life cycle. Especially Annex A, it highlights how these concepts link with international discussions and frameworks around AI governance.
Good to know. So we have this overarching lifecycle model. We see how it's different from traditional software. Now let's get specific. What are the individual stages of the AI system lifecycle, and what happens in each one? Where do we even start?
Well, we should probably start with a general overview of these stages and the processes within them. The standard makes it clear that the processes it describes are just examples,
Mm.
representative examples. What you actually encounter in a real-world AI system, that's going to vary, right? Depends on the system, what it's supposed to do, the context it's being developed in.
So these aren't like strict rules, more like common patterns, common activities that pop up a lot in AI development.
Exactly. And these processes don't always happen in a strict order either. Sometimes you might do them in a different order. Sometimes a bunch of them might be happening at the same time. And some of these processes, like managing costs and resources, those aren't unique to AI, right? But they become way more important in AI because of how AI systems are, their characteristics.
Okay, that's a good foundation. So let's talk about the first stage, inception. What happens when an AI system is just starting out, in its infancy?
Inception, that's where you go from a vague idea to something more concrete. It's that initial phase where stakeholders decide, hey, we want to turn this idea into a real working system. And this inception stage, it's not always a one-time thing. You might revisit it later if something changes or you learn something new, like maybe you realize your idea just isn't feasible with the tech we have today, or maybe it's going to be way too expensive.
So it's like a reality check,
Yeah.
right? Making sure it makes sense to even pursue this idea. What are some of the things that happen during inception, the key processes?
Well, first off, you have objectives. This is all about figuring out the why behind the AI system. What problem are you trying to solve? What need are you fulfilling? What opportunity are you trying to grab? And really important, what metrics will you use to know if you've succeeded? As a listener, think about the AI systems you're interested in. What were their original goals? What impact were they supposed to have? The clearer you are about your why, the less likely your AI system will get lost along the way. Think of it as your North Star guiding your AI development journey.
Yeah, you need a solid direction from the get-go. So what comes after you've nailed down your objectives?
Next up is requirements. This is where you gather all the things the system needs to do, not just during development, but also when it's deployed, when it's being used, and even when it's finally retired. You got to think long term here, or you'll run into problems down the road.
So you're already thinking about how to decommission the system before you've even built it. That's pretty forward thinking.
It is, and it's crucial. To get a good set of requirements, you need people with different skills and viewpoints. This helps you spot risks and unintended consequences that you might miss otherwise. And you can't forget that AI can be unpredictable, right? That needs to be factored into the requirements to make sure you can still reach your objectives.
That's smart, anticipating those unexpected quirks that AI can have. What else happens in this inception phase?
Risk management, that's a big one, and it starts right here. You have to assess all the potential risks linked to this AI system throughout its entire life and create a solid plan to handle those risks. The standard even points to ISO IE 23894, which is all about AI risk management. This involves carefully identifying potential harms and benefits that could come from your AI system, often by talking to representative users and other folks who will be impacted. It can also help define your core values, those guiding principles around legal stuff, human rights, social responsibility, and environmental impact. These values should be baked right into your system's requirements, influencing how it's built, how users interact with it, even the documentation that comes with it.
So it's not just about technical risks, it's about the ethical and societal implications too.
Exactly. And then there's stakeholder identification, which goes hand in hand with risk management. You got to know who's involved in building and using this AI system and who might be affected by it, directly or indirectly. As a listener, who are the stakeholders for the AI you're interested in? Think about the developers, the end users, the people whose data is being used, even broader groups in society.
It sounds like understanding everyone involved, everyone impacted, that's crucial for responsible AI. Now, what about the more practical stuff like money and resources?
Ah, yes, the practicalities.
Yeah.
So you have cost and funding, where you got to figure out how much this whole AI system is going to cost from start to finish and make sure you have the money for it. And then there's Resources. This is a big umbrella covering all sorts of things, but basically, you're figuring out what you need at each stage of the life cycle and making sure you'll have it when you need it. And of course, for AI, especially machine learning, data is a crucial resource. You need training data, validation data, test data, all of that needs to be sorted out.
Yeah, data is like the building material, the foundation for a lot of AI systems. So what's the main goal, the outcome of this whole inception phase?
Ultimately, it all boils down to feasibility. You've got your objectives, your requirements, your risk assessment, your costs, your resources. Now you got to decide, is this AI system actually doable? Is it worth doing? You might even do a proof of concept, a little test run, to see if it can meet the requirements and achieve those objectives. Like, can it solve the problem? Is it a good business opportunity? Can it actually do what it's supposed to do? If it all checks out, then and only then do you move on to the next stage, which is design and development.
So Inception's all about laying the groundwork, making sure everyone's on the same page, and really vetting the idea before you jump in head first.
Yeah.
It's pretty thorough. So what happens next? We move on to design and development, right?
Where things start to get real. That's it. Design and development, that's where all those ideas and requirements from inception start to take shape. The goal here is to build a working AI system, something that's ready for testing and validation. And something really important throughout this stage is to constantly check that the system you're building is sticking to the original plan, the objectives, the requirements, all those things you carefully figured out during inception.
So you're taking that vision, those ideas, and turning them into a real, tangible system. What are the main things that happen during design and development?
Well, the excerpt we have today focuses on one overarching process called approach. This is where stakeholders decide on the overall strategy for designing the system, how it will be tested, how it will be accepted and deployed. It also involves choosing between hardware and software and figuring out where to get those components. Will you build everything from scratch? Buy stuff off the shelf? Use open source tools? These are all big decisions that happen during this approach process.
It's like establishing the blueprint, the roadmap for the system, and figuring out where you're getting the materials to build it. The excerpt mentions other design and development processes in section 6.2.3 of the standard, but it doesn't go into them. What kind of things would those other processes cover?
Yeah, those details aren't in the excerpts, but they would cover stuff like defining the specific architecture of the AI system, choosing the right algorithms and models, designing the data pipelines for training and inference, actually writing the software, and maybe specifying any special hardware the system needs. This is where those abstract requirements from inception are translated into concrete design choices and engineering specifications.
Okay, so you've designed it, you've built it, now you got to make absolutely sure it works the way it's supposed to. Which brings us to verification and validation. What's the difference between those two?
That's a great question. Verification, that's all about checking if you built the system correctly. Did you follow the design specs? Does the code work without any bugs? It often involves a lot of testing, like systems integration testing to make sure all the parts work together, and performance testing to check if the system meets those non-functional requirements, response time, throughput, and all that. For AI systems, verification also means making sure the AI capabilities themselves work as designed, like can the model accurately classify images or predict outcomes? To do this, you use separate test data, not the data you used for development. Think of it this way. Verification is like checking if you built the car according to the blueprint.
So verification is about the how did you build it right. What about validation then?
Validation, that's more about checking if you built the right thing. Does the system actually achieve those objectives you defined back in inception? Does it meet the needs of the users and solve the problem it was supposed to solve? One of the key processes here is acceptance. This is where stakeholders review the system and decide if it's complete, if the quality is good enough, and if it's ready to be deployed. Think of it as taking that car you built for a test drive to see if it gets you where you need to go.
I like that. So validation is more about the why does it actually work in the real world.
Exactly. And something that happens throughout both verification and validation is risk monitoring and review. You're constantly checking the results of all your tests against that risk treatment plan you made during inception. This helps you stay on top of any new events or conditions that might pop up and potentially trigger those risks you identified earlier.
So it's this constant cycle of evaluating and mitigating risks as you move through these stages. Makes sense. And then once it's all verified, validated, and accepted, what next? We deploy it, right? What does it actually entail?
Deployment, that's where you actually install the AI system, release it into the wild, configure it to work in its intended environment. And there are a few key things to consider here. First off, you have the target environment itself. An AI system might be developed in one environment, like a lab, and then deployed in a completely different one, like millions of cars if it's for autonomous driving. Or maybe it's developed to run on client devices, but then gets deployed to the cloud. And sometimes the software and the AI model are deployed separately. The software is like the framework, the foundation, and the model is the brains, the intelligence.
It's like installing an app and then separately updating its data. What else happens during deployment?
Well, there's installation and configuration, obviously, making sure everything is set up properly. Then there's data migration and integration, moving any necessary data over and making sure it works with the system. Sometimes you might need to train the deployed model, especially if it needs to adapt to the specific environment it's in. And of course, there's repair, fixing any issues that come up during or after deployment. And updates, keeping the software, the models, the hardware up to date with new features and improvements. Support is also crucial, helping users with any problems they have. And as always, risk monitoring and review continues throughout deployment, making sure your risk management is still on point.
So it's not just plug and play. It's a whole process of setting it up, supporting it, and making sure it works seamlessly in the real world. Once it's deployed and running, we enter the operation and monitoring phase, right? What happens then?
Operation and monitoring, that's where your AI system is out there doing its thing, and you're watching it closely, making sure everything's running smoothly. There are several things happening here. You have the day-to-day system operation, the AI doing its job, performance monitoring, tracking how well it's actually performing, measuring its accuracy, speed, efficiency, data monitoring, making sure the data it's using is still relevant and accurate, security monitoring, protecting it from cyber threats, user support, helping people who are using the system, logging and auditing, keeping track of everything it does, incident management, handling any unexpected problems, and as always, risk monitoring and review, keeping an eye on those risks.
It's like keeping the engine running, making sure all the parts are working, and being ready for anything unexpected. Now, the standard also mentions continuous validation. How does that fit into the picture?
Continuous validation, that's kind of an extension of operation and monitoring, and it applies specifically to those AI systems that use continuous learning. This means the AI model keeps learning and adapting even while it's being used, on-the-job training. So there's ongoing incremental training happening all the time. And along with that, there's continuous checking, making sure the system is still performing well, using test data, and sometimes even the test data needs to be updated to reflect the new data the system is seeing. And of course, risk management is super important here too, making sure it stays effective as the AI system keeps learning and changing.
It's like the AI is constantly learning and growing, and you're constantly validating and making sure it's on track. So after all that, after operation and monitoring, there's a stage called reevaluation. Why do you need to reevaluate an AI system?
Well, after the system has been running for a while, you might need to step back and take a good, hard look at it. See if it's still doing its job, if it's still relevant, if it's having the intended impact. Maybe its performance has dropped, or the world has changed around it, or maybe you've learned some valuable lessons from its operation. This reevaluation can involve a few key processes. One is evaluating operating results, comparing the system's actual performance to those original objectives and risks. This might reveal that the initial goals aren't realistic anymore or that they need to be adjusted. So then you might refine those objectives, update them based on what you've learned. Similarly, you might refine the requirements if they're no longer valid or if new ones have emerged. And of course, risk monitoring and review continues throughout reevaluation.
So it's a chance to reflect, to see if the system is still on target and make adjustments if needed, kind of like a performance review for AI. And finally, we reach the last stage, retirement. What happens when an AI system reaches the end of its life?
Retirement, that's when the AI system has become obsolete, outdated. It's no longer worth keeping it running. Maybe repairs and updates are too expensive or just not effective anymore. Several things can happen during retirement. You might decommission and discard the system completely, get rid of the hardware, and delete the data. This might happen if the system's purpose is no longer relevant, or if there's a much better alternative available. Or you might replace the system with a newer, better one that can do the same job. This stage also involves data archiving or disposal, making sure you handle the data responsibly, either archiving it for future use or deleting it securely. And finally, there's knowledge transfer, capturing all the valuable lessons you learned along the way so you can use that knowledge in future projects.
So retirement isn't just about switching it off. It's about responsibly shutting it down, taking care of the data, and learning from the experience. Looking back at all these stages, from that first spark of an idea to its final goodbye, it's a pretty impressive journey, isn't it?
It is quite a journey. And the AI system lifecycle, as outlined in Clause 6 of this standard, it gives you this structured approach to understanding it all. It shows that to really understand AI, you have to look beyond its current capabilities. You have to see the whole picture, the evolution, the stages, and how AI-specific considerations play a role at every step.
And for you, our listener, who loves to really understand things deeply and efficiently, understanding this life cycle, it gives you a powerful tool. No matter what kind of AI you're interested in, this framework helps you see how it all fits together, the big picture. And as we wrap up, thinking about this iterative nature, this continuous learning, it makes you wonder, what does end even mean for an AI system? Is retirement truly the end? Or is it just another stage in a never-ending cycle of reevaluation and improvement, maybe leading to a new generation of AI? It's something to ponder, isn't it?
It definitely is. And we encourage you to dive deeper into any of the stages or concepts we've discussed today. This deep dive was just the beginning, the tip of the iceberg. There's so much more to explore in the fascinating world of AI.